Hello grade 9 learners, have a nice day. Welcome back to my channel. For today's video, I'll be discussing to you about combined variation. After watching this video, you will be able to answer the following questions. First, how to determine combined variation. Second, how to translate combined variation statements. And last, how to solve worded problems involving combined variation. First, we have to describe about combined variation. Combined variation describes a situation where a variable depends on two or more other variables and varies directly with some of them and varies inversely with the others. In other words, combined variation is actually a combination of direct or joint variation and inverse variation. The statement z varies directly as x and inversely as y means z is equal to kx over y. So this is a translation of this statement. Or k is equal to zy over x, where k is the constant of variation. Now let us translate some of the statements involving combined variation to equation. But before that, always remember this statement and its translation. If we have here z varies directly as x, z is on the left side of the equation. Then we have the equal sign. After the equal sign, we have here k x in our numerator. Do not forget to write first k because k is the constant of variation and whatever be the variable being assigned for the direct variation, that will be in the numerator. And for the inverse, it will be in the denominator. So here, inverse as y, so y is on the denominator. Varies directly as x is on the numerator. Okay, so this is the translation. Okay, now let's have the first example. The current I varies directly as the electromotive force E and inversely as the resistance R. So we are going to make use of the variables being assigned. So the current we have here I, so it will be placed at the left side of the equation. So we have here I is equal to, do not forget K, varies directly as the electromotive force, so E is on the numerator, while inversely as the resistance R is on the denominator. So this is now the translation. Next, the sales of a product S is directly proportional to the amount A of money spent on advertising the product, but inversely proportional to the price P of the product. So S is on the left side of the equation. We have here is equal to, do not forget K. Directly proportional, this is the same with varies directly. It should be in the numerator. We have here A in the numerator and inversely proportional or inverse varies inversely. It should be in the denominator. So this is now the translation. Third example, the volume V of a gas varies directly as the temperature T and inversely as the pressure P. So V, left side of the equation, is equal to K, then T, and P is on the denominator part. Next, the centrifugal force F of an object moving in a circle varies gently with the radius r of the circular path and the mass of the object, and inversely as the square of the time t it takes to move about one full circle. So the centrifugal force is F, so we have here F is equal to, do not forget K, varies jointly, so we have here R and M, in our numerator and inversely as the square of time. So square, that's why we have here t square. So this is now the translation. Next, the electrical resistance R of a wire varies directly as its length and inversely as the square of its diameter. So R on the left side of the equation is equal to varies directly length KL and inversely, so in our denominator d square, because we have here the square of its diameter. Okay, now you are ready to solve problems involving combined variation. Okay, we have here problem number 1. If y varies directly as x and inversely as z, and y is equal to 22 when x is equal to 4 and z is equal to 6, find y when x is equal to 10 and z is equal to 30. So first, we have to translate the statement. Okay, that is the very first thing that we have to do. We have to translate based on the variables being assigned. So we have to translate this statement. Y varies directly as x and inversely as z. So this is the translation of this statement. Next, we have to solve for our k. To solve for our k, we have to substitute with the given values. So our y here is 22. Just bring down k. Our x is 4, so we have here 4. Then our z is 6, so we have here 6 in our denominator. Now let's simplify. So we have k times 4, that is 4k. Let's copy the rest of the values. Now to solve for k, just multiply 22 and 6 and divide it by 4. So again, multiply 22, this number, and 6, and then 4 will be the denominator. So it is, the denominator is coming from here. Okay, and this is 22, and this is 6. Next, we have to simplify further. So we have multiply 22 times 6 is 132. Then copy the denominator 4. So 132 divided by 4, that is equal to 33. So k is 33, or the constant of variation. Next, we have to solve for our y. We will be using the same equation. Y is equal to kx over z. This time, our k is 33, so we have to substitute our k by 33. Then our x is 10, so we have here 10. And this is our k. And for our z, we have 30. Simplify further. So we have 33 times 10, that is equal to 330. We bring down 30 in our denominator part and divide. 330 divided by 30, that is equal to 11. So meaning to say, y is equal to 11 when x is equal to 10 and z is equal to 30. Another example. If a varies gently as b and c and inversely as the square of d, and a is equal to 120 when b is equal to 5, c is equal to 2, and d is equal to 9. Find a when b is equal to 12, c is equal to 4, and d is equal to 6. So same with example number 1. First, we have to translate the statement. A varies gently as b and c and inversely as the square of d. So the translation for this statement is, we have a varies gently kbc inversely as a square of d, so we have here over d squared. Next, we have to solve for k. We have to substitute with the given values. So RA is 120. We have here. Next, just bring down k. So RB is 5 and RC is 2. Okay, RD is 9. Okay, now we have to simplify further. So bring down 120. So k times 5 times 2, that is 10k. 9 squared, 9 times 9 is 81. Now to solve for k, we have to multiply 120 times 81, okay, divided by 10. So this is 120 multiplied by 81, and this 10 will be the denominator. Okay. Now let's simplify further. So we have 120 times 81, that is 9,720, and divide it by 10. So our answer here is 972. So the value of k is 972. Now we have to solve for a. Okay. We have to substitute with the given values. So our k this time is 972. So we have here 972, and our B is equal to 12, our C is 4, and our D is equal to 6. Now simplify further. So we have 972 times 12 times 4 is equal to 46,656. And 6 squared is equal to 36. Now let's divide 46,656 divided by 36, that is equal to 1,296. So therefore the value of A is 1,296. Next example. The number of minutes needed to solve an exercise set of variation problem varies directly as the number of problems and inversely as the number of people working on the solutions. It takes 4 people 36 minutes to solve 18 problems. How many minutes will it take 6 people to solve 42 problems? So we have to assign first a certain variable to represent for the quantity. So we have M as the number of minutes to solve an exercise set. We will represent P as the number of problems and S as the number of people working on the solutions. Next, we have to translate this statement here. So, the number of minutes to solve an exercise set of variation, we have here M. Varies directly is equal to K, P. Do not forget to write K. And P, number of problems working on the number of problems, and over S, which is the number of people working on the solutions. Next, we have to solve for K. Okay, this is our equation. Let's substitute. So, our M is 36. We have here 36. Okay. Our P is 18. And our S is 4. Okay, next, we have to simplify further. So we have now to solve for our K. So we have 36 times 4 divided by 18. Okay, 36 times 4 divided by 18. Okay, I will put a mark over here, times 4, and this 18 will be the denominator. Now, let's multiply and divide. 36 times 4 is equal to 144 divided by 18, that is equal to 8. Now we have to solve for the number of minutes. Okay, we have to make use of the same equation. Now our K is equal to 8 and our P is 42 because there will be 42 problems to solve. And the number of people to solve is 6. So we have here 6. Now simplify, so 8 times 42 is 336 divided by 6, that is equal to 56. So therefore, do not forget, if it is worded problems like this, do not forget to write the unit. It will take 56 minutes for 6 people to solve 42 problems. Okay, last problem. The electrical resistance of a wire varies directly as its length and inversely as the square of its diameter. If a wire 30 meters long and 75 hundredths millimeter in diameter has a resistance of 25 ohms, find the length of a wire of the same material whose resistance and diameter are 30 ohms and 1.25 millimeter respectively. So we have to assign first a variable to represent for the quantity. So we have R, the electrical resistance of the wire. Next, we have here L, the length of the wire, and D is the diameter of the wire. Next, we have to translate the statement. The electrical resistance of a wire varies directly as its length and inversely as the square of its diameter. So the translation is R is equal to KL over D squared based on the variable that we have assigned. Now we have to solve for K. So this is our equation. Substitute. Our resistance is, we have here 25. The length of the wire is 30. And the diameter is 75 hundredths. We have here. Simplify. So we have 25, 30K, 0.75 times 0.75, that is 0.5625. To solve for K, we have to multiply 25 times 0.5625 divided by 30. Okay, this is now the denominator. Next, multiply 25 times 0.5625, that is equal to 14.0625, divided by 30, and the answer is 0.46875. Next, we have to solve for the value of the length of the wire. So, same equation. Next, let's substitute. So our R this time is 30. We have here 30 ohms. And our K, we have it here 0.46875. L is unknown. Our D is 1.25. We have it here. Then simplify. So we have, bring down 30. That is 0.46875 L. 1.25 times 1.25, that is equal to 1.5625. To solve for L, we have to multiply 30, this one, times the denominator, which is 1.5625. Then divide it with this 0.46875. Now let's multiply. So 30 times 1.5625, the answer is 46.875. Divided by 0.46875, our answer is 100. So therefore, the length of a wire with resistance that is equal to 30 ohms and diameter that is equal to 1.25 millimeter is 100 meters. Thank you so much for watching, guys. Kindly like, and if you have questions, kindly write it in the comment box. Please share to other students, especially to the grade 9 learners, for them to learn or master the lesson. And please don't forget to subscribe to be updated for more lesson videos and turn on the bell for notifications. Before I end, let me share to you one of the verses from the Bible. A wise man will hear and will increase learning, and a man of understanding shall attain unto wise counsels. Proverbs 1 verse 5. That's all for today, and God bless you all.